Hello, dear students. You're welcome to Ark Institute. I am Dr. R.K. Seni, and today I am going to discuss some more questions about the acidic strength. Acidic strength mainly depends upon the stability of their conjugated base, and their stability of conjugated base depends upon many factors like as resonance stabilize, like as inductive effect of other groups, M effect of other groups, as well as solvation of conjugated base. For example, question first. Which one is most acidic? In compound first, NO2 group present at the meta position with respect to phenate ion. After removal of H plus ion, phenate ion meta position. The meta position of nitro group has only minus I effect, but not important effect at their minus M effect because its position is meta. Meta in compound B and in compound C. NO2 group present at the ortho and para position, and we know that ortho and para position effect of NO2 is minus M, and minus M effect is more dominant than minus I. But in case of compound B, important compound B, the NO2 group sterically hindered by the 2-methyl group. Therefore, their electron pair are not involved due to resonance with benzene ring. It means their minus M effect is not applicable in this condition, and this effect is known as SIR, steric inhibition of resonance, and hence it has only minus I effect, and the distance of NO2 group is sufficiently far from the phenate ion. Therefore, its acidic strength is less than the compound number C, third, because NO2 has minus M as well as minus I effect at ortho position. Therefore, phenate ion is most stable, and we know that conjugated base is stable, then their corresponding acid will be strong acid. In compound D, the NO2 is also present at the meta position, and we know minus M effect group present at the ortho and para, then they are more acidic. But in compound B, due to SIR, steric inhibition of resonance, its minus M effect is not applicable, but minus I. Question number second. Check stability of conjugated base with help of the inductive effect of groups. We know that the inductive effect of alkyl group is plus I effect. And when plus I effect group present at the carboxylate ion, then they destabilize carboxylate ion because increases negative charge. Or we know that more negative charge means species less stable. In case of second and third, the carbon is namely sp2 and sp hybridized. And we know that more percentage of S character than carbon has more electronegative. Therefore, their inductive effect minus I effect is also stronger, and hence compound first is more acidic, then second one, and third is least acidic in given. Question number third. The stability of carboxylate ion also checked by the inductive effect of other groups. In oxalic acid, the carboxylate ion, a carboxylic group, directly attached with another carboxylic group, and it's so minus I effect. In case of compound second, minus I effect group is away from the carboxylate ion. Therefore, first is more acidic than second because carboxylic acid minus I effect group directly attached with carboxylate ion, and this carboxylate ion attached with carbon and then carboxylate ion. It means less acidic. In compound third, it is also less acidic because distance, the inductive effect is distance dependent effect, minus I, but distance dependent. In compound 4, the alkyl group, propyl group, has so plus I effect, and we know that the plus I effect group destabilize carboxylate ion, or we know that carboxylate ion conjugated base become less stable, then their corresponding acid is also less stable, and hence most acidic compound first, then second, third, and fourth is least acidic. Question number 4. Question 4. Which of the given compounds are alcohol? We know that alcohols are least acidic compound, and they are weak acid than water also except methanol. When inductive effect of alkyl group increases, then conjugated base become less stable, or we know that when size of alkyl group and branching of alkyl group increases, then their inductive effect become dominant, and hence fourth one is least acidic due to less stable tertiary butoxide ion, and hence first compound fourth more acidic than second, third, and this on. Question number fifth. Question fifth. Check acidic strength of phenate ion with respect to inductive effect of these groups. We know that bromine and fluorine and bromine in compound third, so minus I effect. NO2 is also minus I effect, and NH3 positive is also minus I effect, and we know that minus I effect of a cation is stronger than NO2, then fluorine, and then bromine. Therefore, strongest acid in these questions is fourth, then second, then first, and third. Option number C. Question number 6. Check stability of conjugated base. Carboxylate ion has two resonating structure. These resonating structures are identical, or we can say such type of resonance is known as synchronized. And synchronized resonance is more dominant than unsynchronized, like as in phenol. Phenate ion also undergo resonance, but their resonating structures are unsynchronized, or we can say negative charge of oxygen dispersed into carbon of the benzene ring due to resonance, and hence their resonating structures have different stability. For example, first is more stable than second, therefore such resonance is less effective, and hence we can say acetic acid or carboxylic acid are more acidic than phenol. Alcohols are neutral because no resonance in their alkoxide ion. In case of sulfonic acid, sulfonate ion has three resonating structures. Sulfonate ion has three resonating structure, and in all resonating structure, negative charge delocalized at the oxygen. Or we know that oxygen is more electronegative element, therefore negative charge is more stable. Therefore sulfonic acid are most stable. Sulfonic acid are most acidic. The K of sulfonic acid is much greater than other K of carboxylic acid as well as phenol. Their K is nearly more than 1. The K of carboxylic acid vary from 10 to the power minus 5, and the K of phenol is nearly 10 to the power minus 10. Check the value of K, and we can say their relative acidic strength is much different. Carboxylic acid are nearly 1 lakh times more acidic than phenols, and the sulfonic acid are nearly 1 lakh times more acidic than carboxylic acid, and hence most acidic compound fourth, then acetic acid, then phenol, and then water. B option. Compound number. Question 7. Acidic strength. Incorrect order. Question 7. Incorrect order of acidic strength or in given compound. Compound first. Option first. Water and methanol. In general, alcohols are weak acidic than water, but particularly methanol is strong acid. Methanol is strong acid, slightly strong acid than water, because methoxide ion is more stable than hydroxide ion. The reason this is exceptional case, and the probable reason is the electronegativity of carbon is greater than the electronegativity of hydrogen. It means more negative charge present at the hydroxide ion than methoxide ion. Therefore, methanol is slightly, not more, slightly more acidic than water. Therefore, it is incorrect option. In orthocresol and phenol, when methyl group present at their ortho position, it shows plus H hyperconjugation as well as plus I effect, and both effects make less stable phenate ion, methoxide ion or phenate ion due to their plus H and I. Therefore, cresol is less acidic than phenol. In case of toluic acid, orthotoluic acid and benzoic acid, therefore it is also incorrect. In case of orthotoluic, after removal of H plus ion, the toluate ion has less affinity toward the H plus ion due to steric crowding present at the group which present at the ortho, bulky group present at the ortho position, then the carboxylate ion has less tendency toward the protonation, and this effect is known as SIP, steric inhibition of protonation, and sometimes also known as ortho effect. Therefore, more concentration of H plus ion in the solution of toluic acid, orthotoluic acid than benzoic acid, and hence orthotoluic is slightly is more acidic than benzoic. It is also incorrect. Therefore, all of these are incorrect match. Question number 7. Question 8. Very basic reactions in these questions. First, acid-base reaction. These reactions are very simple and understood by the students of nearly 6-7 class also. Now, we check basic concept about the reaction. In HCl plus NaOH, then NaCl plus H2O. The acid is HCl in reactant side and water is product side. Now, we check more acidic species mainly exist in deprotonated form in the solution. More acidic species mainly exist in deprotonated form, or we can say more ionized form in the solution. Therefore, in forward reaction, HCl gives H plus and Cl. It means more acidic HCl exists in form of chloride ion. Therefore, this reaction is spontaneous, or we can say the reaction is spontaneous forward direction. Question number option C. Alcohol, what NaOH and this. In forward reaction, alcohol gives H plus ion. Therefore, it make alkoxide ion. And in backward reaction, water lost H plus ion and exist in OH ion. Now we check acidic strength of ethanol and water, and we know that ethanol is weak acid than water, or we can say strong acid, comparatively strong acid, and strong acid exists in deprotonated form. Therefore, forward reaction is non-spontaneous, but its backward reaction is spontaneous. Similarly, in case of phenol and water, we can say phenol is more acidic than water, or more acidic exists in their deprotonated form. Therefore, forward reaction is spontaneous. Similarly, a carboxylic acid is more acidic than water, and more acidic species exist in deprotonated form in the solution. Therefore, forward reaction is also spontaneous. Question number 9. Question 9. Similar basic concept. Question 9. Which of the following is non-spontaneous reaction? Or sometimes this question is also asked in form of which of the acid does not gives Briggs effervescence with sodium bicarbonate. When acid react with sodium bicarbonate, then they make H2CO3, and H2CO3 is unstable. Therefore, it evolves CO2, and the CO2 evolve and make Briggs effervescence. Then first question, HCl plus Na2CO3. In example, first HCl is strong acid. HCl is strong acid, then H2CO3. It means reaction is in forward direction. And because more acid exists in form of deprotonated form, HCl exists in deprotonated form, and hence forward reaction takes place. And when forward reaction takes place, then formation of carbonic acid, and carbonic acid produce Briggs effervescence of CO2. Therefore, reaction first is spontaneous. Next, check phenol and carbonic acid. Phenol and H2CO3. Carbonic acid is more acidic than phenol. Therefore, carbon after removal of H plus ion, carbonic acid exists in form of bicarbonate ion. Therefore, in option second, backward reaction is favorable. It means phenol does not evolve CO2 with sodium bicarbonate, because carbonic acid is strong acid than phenol. Carbonic acid, and we can say more acidic species exist in form of their conjugated base or in ionized form. Therefore, backward reaction is favorable in question number in option B, and hence it is non-spontaneous or not evolved Briggs effervescence of CO2. In case of in C, carboxylic acid, benzoic acid is more acidic than carbonic acid, therefore spontaneous. In picric acid 2,4,6 trinitrophenol. when ortho and para position, at least two ortho and para position are occupied by a strong electron withdrawing group like as NO2, CN, etc. Then these substituted phenols become strong acid, then carbonic acid, and they evolve CO2. And when 3 NO2 group present at the 2, 4, 6, then it is known as picric acid. It is more acidic than carbonic acid, and hence it also evolves CO2. Therefore, non-spontaneous reaction is B. Question number 10. Similar conceptual question 10. Identify non-spontaneous reaction among the following. First, acetylene with NaOH gives sodium acetylide and water. Check acidic strength of acetylene and water. We know that water is slightly more acidic than acetylene region because negative charge present at the sp hybridized carbon and negative charge present at the OH ion. OH ion is smaller in size than acetylide, therefore more solvated in water, and hence OH ion is more stable. Therefore, water is more acidic than acetylene, or we know that more acidic species exist in ionized form. Therefore, backward reaction is favorable. Therefore, non-spontaneous reaction. Next, when acetylene reacts with sodium, then it produces hydrogen, and hydrogen gas. Yeah, hydrogen is weak acid than in case of acetylene because non-polar bond, and as forward reaction is spontaneous. In C option, when acetylene reacts with sodium hydride, then also evolve H2 gas. H2 is weak acid than acetylene, therefore forward reaction. In case of third, the product is ammonia, and in case of ammonia, acetylene is more acidic than ammonia because negative charge present at the sp hybridized carbon, and in case of ammonia, amide ion, nitrogen negative charge present at the nitrogen, and nitrogen is less electronegative than sp hybridized carbon. Therefore, acetylene is more acidic than ammonia. Therefore, forward reaction takes place. These are the some questions about the relative acidic strength and their questions and their answers are following. In another class, we also discuss some basic concept of acid as well as basic strength. Okay, thank you. Bye.